Okay, this is our last video, our second video on synthetic division, and this is when you're dividing using a divisor that looks like ax minus k. So you have a coefficient in front of x. Usually what I've noticed is that students will tend to not use synthetic division in this case. They'll use polynomial division. And I do think polynomial division may be more efficient. However, some people are very strong working with fractions, and if that's you, then this synthetic division may still be for you. So I'm going to show you how to do it, and then you can decide whether you'd rather use polynomial division or synthetic division for examples of this type. So we're going to divide 6x cubed plus 5x squared minus 16x minus 15 by 2x plus 3. This 2x plus 3 would have a root of, subtract 3 from both sides and divide both sides by 2, negative 3 over 2. So when we set up our synthetic division, that number that's being written to the, that was a terrible line. That number that's being written to the left of our big L is negative 3 over 2. And the coefficients that are being written above are the coefficients from our terms in decreasing order of power. So we got 6, 5, negative 16, and negative 15. The process looks the exact same. Bring down the number, and then multiply negative 3 over 2 by 6. Negative 3 times 6 is negative 18, divided by 2 is negative 9. Add down the columns, you get negative 4. Negative 4 times negative 3 is 12, divided by 2 is 6. Add down the column, negative 16 plus 6 is negative 10. Negative 10 times negative 3 is 30, divided by 2 is 15. Add down the column, we get a 0 remainder. Here's where it's tricky. These numbers, 6, negative 4, and negative 10, are not the coefficients in our quotient. These numbers are off by a factor of whatever the bottom of our fractional root is. So that means these are off by a factor of 2. In order to get the appropriate coefficients at the very end of one of these division questions, you have to take the numbers you got at the end of your polynomial division and divide them all by 2. The reason why is when you go to expand a polynomial using these coefficients, the expansion will be off by a factor of 8, 2 for each of the terms. And that sounds very confusing, but it's something you could explore. Try writing this as a quotient and taking that as your divisor and expanding it out and seeing if you get back your original polynomial. You don't. What you'll get back is a polynomial that'll be scaled off much higher by a factor of 8. And we don't want that problem. So if we divide each of these coefficients by 2, we get the appropriate coefficients. So now we can write our division statement. Our divisor was 2x plus 3. Our quotient is not with these coefficients, but with these coefficients. So 3x squared minus 2x minus 5. And that will equal our original polynomial, 6x cubed plus 5x squared minus 16x minus 15. I had to squeeze that one in there on the end. I'm not sure why I said it was off by a factor of 8. My apologies, it'd be off by a factor of 2. If we were to expand it out using these coefficients, 2 times 6x squared would give us 12x cubed, and that's not what that term is. Dividing by 2 gives us the appropriate coefficient 3. 2x times 3x squared would give you the 6x cubed. Okay, so a little bit different dividing when we don't have just a single x, when we have, say, 2x or negative 3x. When we have a coefficient in front of our x, we do have to account for it at the very end by dividing by whatever the base of that fraction fractional root is. Okay, that was dividing using synthetic division when your factor or your divisor is of the model ax minus k. You choose which method works best for you. You won't know until you've tried both. So until you've tried an example question using both polynomial and synthetic, you won't know which one you prefer. You may know by appearance. However, you may want to try a couple examples because appearances may be deceiving and you may change your mind. So recommendation is pick a question, try it both using polynomial and synthetic and see which you like better. And then practice and master that method. Thanks for watching. See you next time.